Hello, algebra students. This is Miss Jinners. I'm going to walk you through 813 today. We are going to be doing some more factoring today, and we're going to be extra careful to look for some patterns that can help us factor more quickly. So just as a review, we are using our diamond method to try to factor quadratics. So I'm going to be giving you a quadratic. We have to be careful that it is in standard form. And then we use our diamond where we put AC up top, B at the bottom, A underneath our dotted line, and then PQ, they're kind of our magic numbers that multiply to whatever AC is and add to whatever B is. So if you forgot this diamond, I would jot this down because we will be using it today. Let's get started then. Our first quadratic polynomial is given. So the first thing I'm going to do is just take note of what my A, B, and C are. So A is our leading coefficient because there's no number there. I know that that is A equal to 1. B is my middle term, that's equal to 6. And C is equal to 9. So now I'm going to make my diamond, or more so my X. I guess looks more like that than diamond. Up top, I'm going to put A times C, which would be 9. A goes underneath. And I'm getting a little bit happy because I know that when my A is 1, typically it's a little bit easier to factor. And then B goes on the bottom. So next I'm asking myself, what two numbers multiply to 9 but add to 6? So if you aren't super quick with your factors, your multiplication facts, talk to a teacher about getting maybe a factor chart. But 9 isn't too bad, right? It's either going to be 1 times 9 or 3 times 3. So 3 times 3, that multiplies to 9 but adds to 6. So that's what I'm going to write there. Next, I want to simplify these fractions. So 3 divided by 1, that's going to give me 3. 3 divided by 1, that's going to give me 3. So I know that in my factors, I'm just going to have x plus 3 times x plus 3. So I have the same factor written twice. So actually, I could write it as x plus 3 squared. And one pattern I might notice is that my middle term was 6 and my last term was 9. So it almost looks like I'm starting to see perhaps a pattern when I have the same factor multiplied by itself, right? It looks like my last number was 9, which is 3 times 3, so that makes sense. And then my middle term was double this number here. So that's what we were kind of getting you to think about today. It's just some patterns and shortcuts that we can use later on. Let's try the next one here. This one again is quadratic and it's in standard form. So I'm going to first go through here and make sure I have my A, B, and C labeled. And then I'm going to make my diamond. AC goes at the top. So 2 times 3 goes on the top. B goes on the bottom. And then A goes underneath. And I'm asking myself what multiplies to 6 and adds to 5. So again, use your factor chart if you're not super comfortable with our multiplication facts. But I see right away that 2 times 3 is the factor pair that's going to add to 5. So my next step is to reduce these fractions over here. So 2 divided by 2 gives me 1. 3 divided by 2, that is not a fraction that will reduce. And if you don't know how to tell if a fraction can reduce, please talk to one of your algebra teachers. One of the shortcuts I like to do here is I type in 3 divided by 2, and then I go to math and press enter, and FRAC, frac, that's going to reduce your fraction for you if it can be reduced. In this case, 3/2, 3 over 2, that cannot be reduced. But that's how you would use your calculator to reduce a fraction or see if it can be reduced. So I'm going to write my factors now as x plus 1 and x plus 3/2. But our last step here is to slide. So I've got to slide that 2 out front. X plus 1 times 2x plus 3. That would be my final answer here. So slide and divide is very, very important. One shortcut I ask students to use to make sure they slide and divide correctly is that 2x times x, multiplying your first numbers in each binomial pair here, 2x times x gives me 2x squared. Whereas if I forgot to slide, if you look at my step before, x times x would only give me x squared. So I do not have the correct leading coefficient there. So be really careful that you are remembering to slide and divide. So those are our first 2 examples here. Let's take a look at the next one. So I see that I've got some negatives in the mix now. So be very careful when you see a negative, when you see a minus, that's going to make that coefficient negative. So see, I wrote -7 for C. And if you forget a negative, that will totally mess up your whole process. So be careful here. There's my diamond, my x, so AC goes at the top, so 1 times -7 is -7. B goes on the bottom, and then A goes underneath. And whenever your A is 1, you know that you're not going to have to slide and divide, so that's kind of nice because it's a little bit more simple. So I'm looking for 2 numbers that multiply to -7, but add to 5. Okay. Well, -7 is prime, so I know that 1 and 7 are the only pairs that will get me there. So it's either going to be -1 times 7 or 1 times -7. And I notice in both of those options, I am not adding to 5. Right? I'm not going crazy here. -1 plus 7 would give me 6, and 1 plus -7 would give me a -6. So this tells us that this one is not going to factor into nice rational numbers for us. And so at this point, we can just say not factorable, and we'll find a method later on in this unit for how to get our solutions to these types of problems when it's not rational factors. So for now, we can just let this one go. There's nothing more we can do here. So let's move on to the next one, right? So it is possible that they won't all work out nicely. That's okay, though. We won't be discouraged. So A equals 3, B equals 1, and C equals -14 for my next one. And so again, AC goes on the top, so 3 times -14 is going to go on the top there. Don't forget your negative, that will mess you up. So -42 goes on the top, B is 1, that goes on the bottom. And 3 will go underneath. So -42, so that tells me one of my factors has to be negative, and I want it to add to 1. So this is where it might be a good idea to check out your factor charts if you don't know all the factors of 42 right off the top of your head. So I'm actually going to take a look at my factor chart. So 1 times 42. Okay, so whenever I want it to multiply to a negative and add to a positive one, I know that one of my factors is going to be negative. So one of them has to be negative, and then when I add them together, it has to be a positive one. So I'm really looking for factors that have a difference of 1, right? Since I know one of them is a negative, so it's really like subtraction. So looking here, I'm looking for ones that have a difference of 1. And 6 and 7, those are 1 apart. So those are going to be my P and my Q. Since I want it to add to a positive one, I'm going to make this 6 negative and the 7 positive. So that negative 6 times 7 gives me a negative 42, but negative 6 plus 7 is a positive 1. So that's what I want here. And now my next step is to reduce these fractions. Negative 6 divided by 3 gives me 2. 7 divided by 3, that is not going to reduce at all. So I get x minus 2, x plus 7 over 3. And then reminder, right, this times this better equal this. Oops, we're using m's, and I used x's. My bad, guys. So this should be m minus 2, m plus 7 over 3. My bad. That doesn't change any of our process, right? Just my answer should have m's instead of x's. All right, so that's what I've gotten here. And then again, this times this should give me this. And so you might ask yourselves, wait a minute, I need a 3 out there, right? So we slide and divide. That's our last step here. So m minus 2, there's no sliding there. And then 3m plus 7 would be your final answer here. Because m times 3m, that gives me 3m squared. Alrighty, I've got just enough time to get you started on the next batch of problems. These ones are going to look a little bit different here. So these are called binomials, right? Because one of the terms is missing. My B term seems to be missing. That's okay. We can still do our same process here. So A is going to equal 9, B is going to equal 0, and C is going to equal negative 4. So we can still do the same process here. So AC is going to go up top. So 9 times negative 4 should go up top there. And then A goes on the bottom. So negative 36 up top, 0, B on the bottom. And again, I'm looking, right, what multiplies to negative 36 but adds to 0. So this one's a little bit weird, but consult your factor charts or think about, if I know that something adds to 0, think about when we were eliminating in systems of equations. If something adds to 0, I know I need positive and negative. So I need the same number, but I need one to be negative and one to be positive. So that makes me think of the square root, right, of 36, which is 6. So 6 times negative 6, that will give me negative 36, but adding them together will give me 0. All right, my next job is to reduce these fractions. So I could divide top and bottom by 3 here, right? And I can get 2/3. I divide top and bottom by 3. And then negative 2/3 over here. And so if I put these in my fractions, I will get x plus 2/3 and x minus 2/3. And then if I divide and I slide, I get 3x plus 2, 3x minus 2.